Hello, in this video I am going to talk about interfacing microcontroller pins with relays to isolate signals, other microcontrollers, or very high voltage or current circuits. I had a situation where I had two microcontrollers, one as an output and one as an input. So I had one pin providing a signal to another pin, an input pin. But this caused a problem. Every time I tried to upload a sketch to the input side, the input microcontroller, the upload would just stall. It would not be successful. I would have to manually remove the pin, the connection between the output and input, to be successful in uploading the sketch. And I could have installed a switch between the output and input, which I did not. I did not want to always have to turn the switch off every time I needed to upload the sketch. I already have a lot of switches to deal with Johnny B, the mobile manipulator robot. So, and also, I could have used transistors to have an input, the output signal provide the input signal response. But that is also, that I actually described the schematic in the previous video that I talked about using an AND gate. And I talked about the schematic of that. But I used relays for the microcontroller that had the drive control for the DC motors. At the time, I had two reed switch relays, and that was just a quick method for me to isolate the signals. So I used those reed switch relays. Reed switch relay is the most simple relay there is, where there's the leads to the coil and the leads to the switch leads. So I used the reed switch relays to provide signals from two output pins to two input pins on the microcontroller, and that worked. So every time the output pin received a high, the input would also receive a high, and that's the way I used the relays. So how do you use that reed switch relay or a relay? Because there are many various configurations of relays, but they pretty much have the same method of operation. There is a coil that becomes a magnet once electricity flows in that coil, and the magnet attracts the switch, which closes or opens the switch depending on the version that you're using, and that controls whether electrons flow from one end of the switch to the other. So in this situation here, I have two separate grounds. So this is this help you to have two isolated circuits. So if you were dealing with very high voltages or currents in one separate circuit, and you did not want to risk damaging your separate circuit that only used lower voltages or current, you can use this relay system also. So there are two grounds in this circuit, ground 1 and ground 2. And here's the output side of the circuit, which is from here over, and the input side of the circuit is from here over. So the left side is the output circuit, and the right side is the input circuit. So I'm going to explain the way this works by describing the functions within this schematic. Okay, so this left side is for microcontroller 1, This right side is for microcontroller 2. I have an output pin on the left side and I have an input pin on the right side. If you follow the path of the electrons flowing in this schematic, you will see that there are two separate paths. There's no common ground, so the circuits are completely isolated from the left side and right side. And here I have a 240 ohm resistor, but that really is the resistance of the coil, but I represented that as a series resistor here. So in other words, I did not install a separate resistor in this series circuit here. And just note that I actually use two sets of this circuit to provide signals from two output pins of one microcontroller to two input pins of the other microcontroller to the microcontroller that controlled the DC motor drive system. But keep in mind that I actually in that video I mentioned that I had to remove one LED. This is an LED, one LED, because they did not function exactly the same. Depending on the voltage and current for the pins and the individual component characteristics, one in the situation previously, an LED was consuming too much power, which did not allow the coil to become magnetized strong enough to flip the switch. So I had to remove the LED from one of the two circuits. So in this instance, I have, once the output pin provides a high signal, electrons flow from ground to that pin, and the LED would light up if you have an LED that works. So I have this as my primary circuit, and this is my secondary side circuit. So on the secondary side circuit, once this coil becomes a magnet, the switch flips and then connects from this lead to that lead. The contacts touch on this switch, then electrons flow from this point to that point, and then through the resistor to the input pin. So I actually installed a 330 ohm resistor to protect the current and voltage of the input side of that microcontroller. So that's the way this circuit works. The switch closes, electrons flow through the switch and to the pin, and then this pin receives a low. So this pin has to be on high as the default and in the microcontroller. And once this switch closes, the pin receives a low signal. So that's one thing you need to consider when you program your input, that you need to have it as high and set the condition that when it's low, that's when the condition changes. And this is called a reed switch relay. As you can see, there's two leads for the coil and two leads for the switch. This side of the circuit schematic or the circuit controls the coil magnetism, and this side of the circuit controls whether electrons flow through the switch. I hope this has been helpful. As in the previous video, I used one common ground with a transistor. You can replace this reed switch relay with a transistor if you are not dealing with high voltages or currents, and you can actually just use a transistor, which I've shown the function of in a previous video. So you can replace that with just one common ground. This will be the base, and that will be the collector and the emitter as the ground of a transistor. But this is helpful in the cases that you want to isolate your circuits. I hope this was helpful. Thank you for watching.